To start this example, I'm going to go ahead and sketch the asymptotes that are not identified in the choices given for this question. Asymptotes are invisible, so really a test or quiz doesn't have to include them in the graphs. I'm going to add them in to help you guys identify which of the following graphs matches the equation. The exponent has an x plus 2. That means our graph needs to move to the left 2 units. On the end of our equation, we have plus 1. That means our graph has to have shifted up 1 unit. The 6 is the base of the exponential. That means we have an exponential growth function. As long as your base is greater than 1, you have an exponential growth. If that number were something between 0 and 1, we would have had a decay. There's no reflections anywhere, so by process of elimination, the answer is A. Next, we have an example that asks us, how does the graph of y equals 2 times 2 to the x compare to the graph of the parent? By the parent, we mean the parent function, and the parent function in this case is going to be y equals 1 times 2 to the x power. There are many different parent functions for exponentials, all of them having a different base. The a value out front for every parent function is a 1, and there are no horizontal or vertical shifts, no reflections, and no stretches or compressions. The 2 out in front indicates that our graph has experienced a vertical stretch of 2. That means the answer to this question is A. In choice B, y equals 1 to the x isn't even a parent function. For exponential functions, the base can never equal 1, and the base must be a positive number. So that choice makes no sense. While choice C has the right parent function, it describes it as moving to the left 2 units, and that's inaccurate. The last choice is inaccurate in 2 ways. It isn't going to the right 2 units, and y equals x is not the parent function, that's the parent of a linear function. Y equals a base raised to the x power is the parent function of an exponential function. A, h, and k indicate some common transformations. A equals 1 and k equals 0. These are our default values. H, however, equals 6, and x minus 6 means our graph moves right 6 units. After inspecting the choices, we can see the answer must be C. So again, just to reiterate, y equals 4 to the x is the parent function. B is never allowed to equal 1, and b must be greater than 0. When you have an example 4 raised to the x plus 6, that would move your graph left 6. If you had an example 4 to the x plus 6 on the side, your graph moved up 6. 4 to the x minus 6 moves your graph down 6. As soon as you see in a word problem that something is changing by a certain percent, that's a giveaway that we're dealing with an exponential function. Exponential functions, as we've seen, come in the form y equals a times b to the x. You may also write your equation as y equals p times the quantity of 1 plus r to the x or t power. These are really all the same thing. 1 plus r represents our base. Now, as we analyze our rate, we see that we are increasing, which means positive, by 2% per year. 2% means 2 out of 100, and 2 divided by 100 gives us the decimal 0.02, or 2 hundredths. The cost initially started at $3.19, which gave us p equals 3.19. C of n is what they ask us to use for our function, so we'll use p, which is 319, times 1 plus r, 1 plus 0.02, to the n, because C of n tells us that our input or independent variable should be n. At the end of the word problem, they even tell us in n years. Before we move on, I'd just like to address the wrong answers. Choice A is an exponential function, but it shows that it is decreasing by 2%, and then choice B and choice D both show us linear equations, and we are not looking for linear in this case. Ellen put $6,000 in an investment account. She earns 5.9% interest per year. After how many years will Ellen be closest to doubling her starting investment? The first thing we should really catch is that she's earning 5.9% interest per year. That's a dead giveaway that we're working with an exponential equation. She puts $6,000 in, that's P, our initial investment. The 5.9% interest per year as a decimal means we're adding 0.059. The question starts off by asking us after how many years. This means we're going to be solving for the time variable t. We want to know how long it's going to take for Ellen to double her starting investment. We could fill in $12,000 for A, or the amount at the end of the investment. Isolate the base to a power by dividing both sides by 6,000. 2 equals 1.059 to the t power. Whenever you're solving for an exponent, you need to use the inverse of an exponential. The inverse of exponential is log. We're going to default to the ln, or natural log. If we take the natural log of both sides, we could also apply the power property, which allows us to bring the t variable out front and is what we really needed the whole time in order to solve our equation. Last step, we're going to divide both sides by the ln of 1.059, which gets us our final solution. T equals approximately 12.092 yada yada yada, so 12. Choose the equivalent equation in logarithmic form. There are two forms of logarithmic equations. The first form we have is exponential form, and the second form is logarithmic form. You should know both of these equations by heart. b to the y equals x, and log base b of x equals y. My base in both examples is 6. 4, my exponent, is the y value. And 1,296 is the x value in these two equations. Now all I need to do is identify which choice has everything in all the right places, and that choice would be A. My explanation isn't going to go into as much detail this time because this example is exactly like the last example. We're given exponential form and we're expected to change this into logarithmic form. My base is the number being raised to the power. That's always the number you should pay attention to first. The base of an exponential presents itself as the subscript or base of a logarithm. Finding this in your choices will probably help you narrow down your options. This next example actually requires us to pay attention to the same formatting as the last two examples. Even though we have an expression and not an equation, we could assume that when it asks us to evaluate that logarithmic expression, it does equal some invisible y, and that's what we're trying to figure out. It's really important that we know how to read a logarithmic expression. The way you read something like this is b to what power is x. This really brings us back to the two forms of a logarithmic equation, log base b of x equals y and b to the y equals x. It's really giving us the same question that we just wrote out with words. Whether we start this out by just thinking of the words or by changing it from logarithmic form to exponential form, we will get 5 to the y, or some other variable, equals 1 over 625. I'm going to solve this one by using a swap-portunity. 625 is actually 5 to the 4th power. 5 to the 4th power in the denominator is actually 5 to the negative 4th power. One-to-one property says we could ignore those two 5s and conclude that y must equal negative 4. And since y is what we had set our original logarithmic expression equal to set up this whole problem, our answer must be C, negative 4. Just as a quick review of negative exponents, 5 to the negative 3rd, if A were the answer, would equal 1 over 125. 5 to the 5th power, if B was the answer, would equal 3,125. And last, 5 to the 4th power is just 625. This example is quite similar to the last example. However, we are working with common log this time. Common log has no subscript written out more often than not. Common log is log base 10. Please try not to confuse this with natural log. Natural log, or ln, is log base e. So again, common log, even if you look at the first two letters of the word log, kind of looks like a 10. So try your very best to remember that a plain log is log base 10. Next, 0.01 is a decimal that we say as 1/100. As a fraction, we write it just as it sounds, 1/100. Now we ask ourselves, 10 to what power is 1/100? Since 10 to the second power is 100, that means 10 to the negative second power is 1/100. So we're really asking ourselves, 10 to what power is 10 to the negative second? And that question answers itself. The answer is -2. If you need extra support with this example, you should definitely look at numbers 6, 7, 8, and 9, as they all support exactly what we're doing here. We're taking our logarithmic form and converting it to exponential form. Earlier this school year, we graphed several parent functions, including log. Log was one of the examples you asked to go over several times. I think more than anything, it was the fact that you were very unfamiliar with this new function, so I hope that you're more comfortable with it now. I hope you still remember that log is the inverse of an exponential. That means that its graph will look like an exponential function had been reflected over the line y equals x. This has to do with the changing of the domain and range, or input and output, or x's and y's, however you decide to look at it. In order to graph a logarithmic function, we focused on 2 points. The 2 points I wanted you to focus on were over 1 up none and over the base up 1. To have more explanation on how to graph a logarithm and to understand where these 2 points come from, you could definitely check back at some of our older lessons. Also, please remember that over 1 up none and over base up 1 is coming from the vertical asymptote, or really the point hk, and not necessarily from the origin. In this case, it will be from the origin because the logarithmic function hasn't been shifted left, right, up, or down. Another word for shifted is translated. There's really only one option that has even remotely close to the right shape, so we definitely investigated choice C first, which ends up being the answer. To begin this problem, it's important that we ask ourselves, 9 to what power is 27? Now, you don't want to get tripped up and accidentally say 3, because 9 times 3 is 27, but 9 to the third is not 27. In order to solve this problem in the easiest way possible, we're first going to take this log, base 9 of 27, and set it equal to y, so we could think of it as a logarithmic equation instead of an expression. This also allows us to turn this around into exponential form instead of logarithmic form. We like to look at this one in logarithmic form because it's a perfect candidate for us to use a swappertunity. Both the numbers 9 and 27 can be written as the base 3 raised to a power. 9 can be replaced with 3 to the second, and 27 can be replaced with 3 to the third. 3 to the second to the y becomes 3 to the 2y, because when you raise something to a power and then raise that to a power, we multiply the exponents. We then have 3 to the 2y equals 3 to the third, and then we use 1-to-1 property, set 2y equal to 3, divide both sides by 2, and get that y, or log base 9 of 27, equals 3 over 2. 3 over 2 is the decimal 1.5, but we're going to leave our answer as a fraction. Rational exponents are more frequently used than decimals. The rules for transformations apply the same to all parent functions. The 2 coefficient in front of our logarithmic equation is often represented by a lowercase a during lessons in class. The x plus 5 is often represented as x minus h, and we just happen to not have a plus k in this example because our plus k is really plus 0. The x minus h we called our crazy house. That moves our graph left and right, and we say it's crazy because it's the opposite of what you would normally expect. X plus 5 will move our graph then to the left 5 units. A is our vertical stretch or compression. When the value is larger than 1, ignoring any negatives out front, it's a vertical stretch. And if the number is between 0 and 1, again, we don't pay attention to any negatives for this, it would be a vertical compression. Which choice has all of this criteria met? The answer for this question is going to be A. The quickest way to do this problem is to simply ask yourself, 9 to what power is 81? If you can do that, you'll be done immediately. I'm going to show work, however, asking myself 9 to what power is 81, and then coming to my solution by using swaportunity and 1-to-1 property.